Picking up where we left off, we've already explored if we have holes or no holes. Now it's time to look at all asymptotes, vertical and horizontal. So for each problem, I'm going to start with the vertical asymptotes. Vertical asymptotes occur where the denominator equals 0, but not the numerator. So in all of these cases, we're going to set the denominator equal to 0 and solve. So let's subtract 1 and divide by 3. The result is x squared is negative 1/3. Let's bring in the square root. We know this is going to be I square root of 1/3. So it's I square root of 1 on top is just 1. Square root of 3 in the denominator stays. Remove the absolute value. So what does this tell us? It tells us that there are no vertical asymptotes on this graph. That's okay. You don't have to have a vertical asymptote. This graph doesn't have any vertical asymptotes. That's fine because we have imaginary solutions. So I'm going to come up here and I'm going to document that. I'm going to record that. No vertical asymptotes. All right, for the horizontal asymptotes, we can look at the other side of this worksheet. We want to identify N and M. N is the highest degree in the numerator, and M is the degree of the denominator, 2. Compare. Well, then N is less than M. What that tells us is that the horizontal asymptote is y equals 0. You can graph this function in your calculator and see that it has no vertical asymptotes. The domain must be all real numbers, but it must be that the graph is approaching the x-axis on both the far left and the far right. All right, B. Let's explore the vertical asymptotes. Set the denominator equal to 0 and solve. Square root of 1 is just 1. Remove the absolute value. It looks like we're going to have two vertical asymptotes, one at x equals 1 and one at x equals positive or negative 1. X equals negative 1 and x equals positive 1. Now let's look at the horizontal asymptotes. So we want to identify N and M. We want to compare, so N equals M. When the degrees are the same, we do have a horizontal asymptote. It's not 0, it's the ratio of the coefficients of those two terms having those exponents. 2 over 1, which is just simply 2. So if you were to graph this equation on your calculator, you would see that there's a break on the graph at x equals negative 1, x equals positive 1, but the graph is approaching y equals 2 from the far left and the far right. All right, C. Let's find the vertical asymptotes. Disregard the numerator. The vertical asymptotes, like the domain, is all about the denominator. The vertical asymptotes occur at the zeros of the denominator. This trinomial is going to factor. Set each factor equal to 0 and solve. Oh, sorry, x minus 1 equals 0. I went straight to the vertical asymptote. Neither one of these x values contribute to holes, so they're both vertical asymptotes. Oh, sorry. Oh my goodness. X equals 1. These are both x's. All right, horizontal asymptotes. Let's identify the degrees of the numerator and denominator. N is 2, m is 2. As in the previous example, when n equals m, we look at the coefficients on those terms. The horizontal asymptote is always y equals. So we have 5 and we have 1. 5 over 1 is just 5. Part D that has no holes, vertical asymptote. Don't look at the numerator, only focus on the denominator. These are the restrictions of the domain. I wouldn't put positive, negative on 0. I'm just going to do 0. One vertical asymptote, it occurs at x equals 0. Horizontal asymptote. All right, in the numerator, you can include x to the 0. So n is 0 and m is 2. The way these two compare, well, n must be less than m, I guess. Makes sense. So if you look at the other side, when the degree of the numerator is less than the degree of the denominator, we have a horizontal asymptote on the x-axis. And the equation for the x-axis is y equals 0. All right, I'm going to set the denominator equal to 0, but because I've already done previous work with this and factored the denominator, I'm going to set the factored version of the denominator equal to 0. All right, before we quickly say that the vertical asymptotes occur at x equals negative 2 and x equals 3, look back, we had a hole at x equals negative 2. So we can't have a vertical asymptote when we have a hole. So in this case, we only have one vertical asymptote, and that vertical asymptote occurs at x equals 3. So lightly crossing this off, we're just indicating that we don't have a vertical asymptote because it is a hole. All right, let's look at the degrees. We'll look at this version right here, not the factored version. They're equal. The degrees are. The rules are the horizontal asymptote occurs at the ratio of the coefficients. So 1 and 1. 1 over 1 is just 1. So this graph, if you were to graph it in your calculator, is going to have a hole at x equals negative 2. It almost looks like there's not a hole because when you graph it, it comes together. It's just the calculator has issues. But if you were to hit trace and then hit negative 2, there would be no y-coordinate that belongs to x equals negative 2 because there's a hole. So the only vertical asymptote that you'll see as a visual would be occurring at x equals 3, and the graph comes on and leaves the screen near the horizontal line y equals 1. All right, final problem, vertical asymptote. Let's go ahead and capture the factored version of the denominator. Double checking, we have a hole at x equals negative 5, so this is an extra or extraneous vertical asymptote. So the only vertical asymptote that we would see on the graph would occur at x equals 0. And for the horizontal asymptote, we've seen this before. N is 2, and m is also 2. So we're stating that m is equal to n, And in that case, we know we have a horizontal asymptote at the ratio of the coefficients. Well, these just happen to be 1 and 1, so again, the horizontal asymptote occurs at y equals 1. Alright, so in this video we found vertical and horizontal asymptotes and if there were any holes on the graph as well.